Okay, so this is problem 1.2 out of Griffith's Electrodynamics. Before I kind of go through this, please like and subscribe. I'd appreciate it. And if you have any problems you'd like to suggest, you can message me on Twitter at PhysicsHelping. So is the cross product associative? If it is, prove it, and if not, give a counterexample. So the cross product is not associative. The trick here is to find vectors where you can see that to be the case. So it was a little tricky, but ultimately what I ended up doing was picking these set of vectors. And the reason why I did is, well, I'll show you. So we're going to use our right-hand rule, A cross B. So you put your fingers in the direction of A, and you cross them in the direction of C. So you put your fingers in the direction of A, and then you rotate, of course, your right hand. It's the right-hand rule. So your right finger's in the direction of A. Rotate your hand until you can comfortably curl them in the direction of B, and you should get a resulting vector like this. So this is A cross B. Notice that this vector, the blue vector, is mutually orthogonal to both A and B, which is what the cross product kind of guarantees. So now we want to take that vector and we want to curl it in the direction of C, because we have A cross B, and now we're crossing it with C. So if I do that, what you'll end up finding is, and I'll do this in blue again, that the resulting vector, this one, A cross B, cross C, points up in the y-hat direction. Okay? Now, we can actually kind of stop here, because if we look on the other hand, B cross C is going to be 0 because they're parallel to each other. They're anti-parallel to each other. So any vector cross 0, the 0 vector, is just 0, which clearly, or at least in general, 0 does not equal A cross B cross C. Okay? So that's kind of the way that I ended up working it out. Maybe there's a better way, but that was a counterexample I found. So again, you can use your right-hand rule, point your fingers in the direction of the first vector, your right-hand fingers, rotate your hand so that you can curl your fingers to the second vector, and your thumb points in the direction of the resulting vector. And then keep in mind the fact that the cross product gives mutually orthogonal vectors, and you should be able to eventually play through a solution. So hopefully that helps, and if it did, please like and subscribe, and I'm going to try to do more problems, as many as I can.